Good morning, dear students. Welcome to PURNACHANDRA Higher Secondary School. Okay. So, in the previous class, we are discussing about the dimensional analysis applications. Okay, and about some of the tricks how to find out some of the rules how to find out the significant figure. Okay. So these are the things we have discussed in the previous video. Clear? So in this class or in this session, we are discussing about a very new thing or new topic, that is error. Clear? Which is very familiar to us in our day-to-day lives. So now let us discuss first of all how we will face the error during the measurement of any physical quantity. Clear? So before that, let us discuss some of the very important few things. Suppose we have any physical quantity with us, any physical quantity, and we want to measure that physical quantity in the lab, experimental laboratory. Clear? Then what happens? Actually, that physical, suppose a physical quantity is provided to us, any physical quantity, okay, is provided to us, and what is our aim? Now we have to in the experimental lab, I have to find out the value of this physical quantity. Clear? So we know that any physical quantity, what is going to be analyzed or measured in the laboratory, that is having a true value or a standard value. So I have to mention here, that is having a true value or standard value. Listen very carefully. Clear? That is already given to us. A true value and standard value is given to us before performing that experiment. Clear? So now in this laboratory, when we are performing the experiment, okay, we are getting some values. We are getting some values of that physical quantities. Clear? That values are called measured values. That value are called measured value. Clear? Then, so we have two values with us. One is true value or standard value. Clear? The true value and standard value is already given to me before performing the experiment. It is already provided to us of this physical quantity. Number one. Number two, when we are performing the experiment, after getting the results, we will get some values. They are called measured value. All of you clear? Okay. So now that if the measured value is equal to true value, remember very carefully. Listen very carefully. If the measured value is equal to true value, then we will call the experiment is perfectly done. There is no error. Okay. But practically it is not possible. Practically, if we are doing some experiment, then there must be a difference between these two, because no system in the world is error free. There is a very singular individual error must be there. Clear? Okay. So now, that's a very simple definition of error. We can call it as that the difference between the measured value and true value. Remember, the difference between the measured value and true value is called error. Very simple. Clear? Okay. So the difference between whatever we have measured after performing the experiment and what is the true value provided to us, the difference between these two, remember, the difference between these two is called error of an experiment or error of measuring a physical quantity, any physical quantity. Understood? Okay. So now, this is a fundamental thing. We will clear that what is an error. Okay. So now there is another, in the error part there are another very two important terms. Okay. The first term, number one, is your accuracy. Okay. And number two is your precision. Clear? These are the very two important terms during calculation of an error. Remember, what are the two terms? One is accuracy, another one is precision. So let us discuss some points about these two. What is accuracy and what is precision? Again, we will move to that same concept. Okay. So what is accuracy? Very simple. If the measured value or accuracy provided to us, how the measured value is close to the true value. how the measured value is close to the true value. Clear? As the measured value is close to the true value, then we will call that the experiment or the value will more accurate. Understood, all of you? Clear? So if we will define accuracy, then what we will define? The accuracy is defined as the measure up to or the measure how the measured value is closer to the true value of n physical quantity. The measurement of n physical quantity. Very simple. If the measured value is more closer to true value, then it is more accurate. Very simple. And if it is not closer to true value, then it is less accurate. Understood all of it? Okay. Then come to the precision. Again the same concept. If the measured value is more close to the true value, it is more accurate. How we will define or how we will know that it is more accurate? From this precision value, that is the limit. The limit up to which it will be precised. Very simple. The limit up to which we can precise the value. Precision. The limit of measurement gives me the precision. That is the main point. Let us take an example, then it will be very much clear. Suppose I have a watch. Listen very carefully. Suppose I have a watch which is having I have a digital watch actually, which is measured up to second hand. That is, suppose at that moment we have the watch shows that 10 hour, 30 minute and 15 second. Listen very carefully. Okay, so it is shown in my watch. That means we can say that it is having how many it is precise up to the second. Very simple. Okay, but at the same moment, suppose my grandfather has a watch. Okay, but the watch which is along with my grandfather has no second hand. Clear? Then what time it will show? Now at the same moment it will show that it is 10:30. Then can you tell me from these two values which is more precise? Which is more precise? That is very much clear that the watch which is having with me is more precise than the watch having with my grandfather. Because it is more precise means it is shown up to particularly 15 seconds. So it is more precise, it is more accurate time. It shows the more accurate time. The measured value is more closer to the true value. Understood all of you? Clear all of you? So that is the difference between these two. Okay. Then another very important point is that is least count. It's a very important term. Remember least count. Let us discuss about the least count. So when an instrument is provided to us, okay, so every instrument in the world have a minimum measurement. Listen very carefully. Have a minimum measurement up to which the instrument can measure accurately. Clear? Okay. Just for example, take the same thing. Suppose a watch which is having a hour hand, a minute hand, and a second hand. Remember, that is having with me the my watch. The above example. Okay. So here I have a hour hand, I have a minute hand, and so also I have a second hand. That means in my watch, what is my least count? Or what is the minimum measurement I can measure accurately? Now 1 second. Very simple. 1 second. Clear? Okay. Whereas come to the second point. Or the watch which is having with my grandfather. This watch is having no second hand. It is only a hour hand and a minute hand. So that's why it shows 10:30. Okay. So what is the least count or what is the minimum measurement the watch which my grandfather can measure? That is your 1 minute. Clear? So from these two, it is having a least count 1 second, and if this watch with that is along with my grandfather can measure up to 1 minute. So from these two examples, which is more accurate or which is more precise? Move on. Very simple. Clear all of you? So that's why least count. Remember, again I'll repeat one thing. Least count is nothing but the minimum measurement up to which a instrument can measure accurately. For example, you can take a scale. Okay, so a scale, suppose a 30 centimeter scale. Suppose so a scale is giving 30 centimeter. So 1 centimeter, 2 centimeter. If you watch the scale, 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, up to 30 centimeter, and each suppose this is 1 centimeter, this is 2. This is suppose 1 centimeter, this is 2 centimeter. In between these two, how many divisions are there? If you look at the scale, how many divisions are there? 10 divisions. Is there any scale available? There is 12 division. No, practically not possible. So there is available 10 division. That means we can tell that 10 division is equal to 1 centimeter. Very simple. So 1 division is equal to 1 by 10. That is 0.1 centimeter. That means what is the least count of a scale? What is the least count of a scale? 0.1 centimeter. I think all of you understood. That is with the help of scale, what is the minimum measurement we can do? 0.1 centimeter. Below that we cannot perform the experiment perfectly with that scale. Okay? Suppose we want to measure 0.01 with a scale. Can you measure it? No. Why? Because 0.01 is lesser than 0.1. And we have the least count in that scale is 0.1. That's why we cannot measure 0.01 with a scale. Clear of you? So that is the main concept about the accuracy, the precision, and the least count. Understood all of you? Clear? Okay. So remember one very important point lastly I want to tell you. As the least count, remember, as the least count value is depend upon the accuracy, or we can tell precision. Clear? Because as the least count is more, the measurement is more accurate. Clear all of you? Okay. So these are the some of the fundamental things. First of all, we will discuss in case of your error. Most fundamental thing and most important thing. What is accuracy? What is precision? What is least count? I gave the examples and what is an error actually. Clear? So now next part we will move into the types of errors. I think all of you clear about these things. If you have any of the doubts, if any, then you can ask me freely. Okay? Now let us discuss about the types of errors. Okay. Errors generally basically universally two types. One is a systematic error. The second one is a random error. Okay. So one is a systematic error. Your second one is a random error. So let us discuss about first about the systematic error. Let us discuss about the systematic error. Okay, all of you. So let us discuss about the systematic error. So what happens if a systematic error? The systematic error are your what you call a particular directional error. It is having a single direction. What does it mean? It means the systematic error, whatever we will get during a measurement of a physical quantity, that error, either it will have a positive value or it will have a negative value. Remember, it cannot be both in the same time. That's why it is unidirectional. Remember, the systematic error, the name is a systematic. Remember, this is systematic. That means either the value of the error can be negative value or the value of the error can be positive value. It can be both simultaneously. Remember, okay? So that's why it is the unidirectional error. Its value either the value can be either positive or there is a slash or negative. It cannot be both simultaneously. Clear all of you? Okay. So that is unidirectional. I mentioned here that is unidirectional. That means either it is positive or it is negative. Either it will give a positive value or it will give a negative value. So systematic error generally of three types. Number one, let me listen very carefully. The systematic error first. Number one, is your instrumental error. Instrumental error. Okay, instrumental error. Okay, then number 2, error. Remember, number 2 is error due to improper technical method. Okay, error due to improper technical method. Okay, number 3, so first is instrumental error, number 2 is error due to improper technical method, and number 3 is your personal error. Number 2 is your personal error. Again I will repeat, personal error. So what are the 3 things? Let us discuss one by some points. Okay, so first of all is the instrumental error. So very simple, if the name indicates the instrumental error, so this type of error arises due to malfunctioning, or misuse of this, or your malfunctioning, or what you can call any instrument. Suppose the instrument is provided to us or provided to a user, okay, and it is having a fault within that instrument. Then due to that the faulty in that instrument, whatever the error arised during performing the experiment, okay, so that type of error we call it as a instrumental error. Specifically the error due to instrument, the improper functioning of the instrument, okay, is called instrumental error. Very simple. Clear all of you? Okay, anything. Suppose we have a vernier caliper, we have a screw gauge, suppose a vernier caliper. Then what happens during the calculation with the help of a vernier caliper? Suppose the vernier caliper is malfunctioned. It will having the least count, we cannot set it due to the manufacturing defect. Then whatever the error arises during the calculation of the length with the vernier caliper, okay, so that type of error is called your instrumental error. Understood? Then come to the second type, that is error due to improper technical method. Okay, so improper technical method means suppose an instrument or a setup is provided to us. Listen very carefully, but unfortunately the user do not know how to operate it. The technical functionality the user do not know. Then what happens? Now the experiment will not perform correctly. There will be fault at the result. Clear? So whatever the fault or whatever the error arise due to that process, okay, that type of error is called improper technical method. Example I can take it. Suppose I want to measure the temperature of my body. Clear? So for that what I want a thermometer, and I want to place that thermometer perfectly to my body. Clear? Because why? Because if the thermometer is not placed perfectly or perfectly not tossed to our body, then the temperature of my body it shows can vary. Because the temperature of human body also depend upon the external factors such as pressure, such as humidity, etc. So that's why it is very important that to measure the human body temperature, the thermometer should be placed accurately and perfectly. So if it is not accurately placed or perfectly tossed to the human body, then whatever the error arised, that type of error comes within systematic error. Remember, and that type of error is called error due to improper technical method. Understood? Okay. Then come to the third one, that is a personal error. Personal error means suppose one performing an experiment and that person do not know how to operate that instrument. That is instrumental biasing, okay, or misuse of that instrument. Understood? Clear all of you? Okay, because as the user do not know how to operate that instrument, then whatever the errors arised, that is called your personal error. So the error arises due to the personal biasing or personal misuse. Remember, that is the word misuse. Okay, or carelessness. There is a very important word, carelessness. Okay, so that type of error is called personal error. Clear? Okay, during any type of measurement or any type of performing experiment in the laboratory, okay, due to the personal carelessness or due to the personal biasing, okay, carelessness or misuseness, whatever the error arises, that is called personal error. Clear? So, and remember, these three errors comes in between the systematic error, and these three errors, either it will give the positive result or it will give the negative result. It will not give both positive and negative simultaneously. I think all of you clear? Okay. So next, move into the second type of error, which is very important. Okay. Second type of error is actually our main concentrate on this type, that is the random error. Here, the second type is your random error. Look at very carefully how the random error can be calculated. So as the name here random, listen very carefully, as the name here random, so that's why that type of error is unpredictable. Understood? That type of error is unpredictable. Clear? So that's why it is named as random error. There is a certain process by which we can find out that type of error, random error. Clear, all of you? Okay. So specifically the random error are unpredictable error and irregular error. Clear? Because why it is irregular? It is not a regular one. It is irregular one. It is unpredictable one because its value can be positive, can be negative, or can be both. Understood, all of you? Okay, because it is not systematic. Systematic one is either it is, or if it is positive, it cannot be negative. Clear? But random one is simultaneously it can be positive and negative. Clear? Okay. So random error. So the two important points in random error are unpredictable and irregular. Unpredictable and irregular. These are the main two things. Clear? So let us find out or let us discuss the process by which we can find out the random error of a physical during your measurement of a physical quantity. Understood? So let us discuss. So suppose a physical, listen very carefully. Suppose a physical quantity A is provided to us. Suppose A is a physical quantity, okay, provided to us. Clear? So now we were performing an experiment on that physical quantity. Okay. So during the experiment, what are the values we will get? A1, A2, A3 up to AN. Listen very carefully. So what are the measurements or what are the values we will get? A1, A2, A3, AN. These are the values or these are the measuring values. Measured values, remember. These are the measured values we will get during your performance of my experiment of that physical quantity A1, A2, A3 up to AN. Okay. So what is our aim? The one by one, step by step we will get. Okay, we know that. What is error? First of all, what is error? Now, error is the difference between the measured value and the true value. Very simple. Error is the difference between the measured value and true value is called error. Okay, so here one by one we have to get the first point we have to first find out what is the mean of these values. Okay, so mean, I have to mean, let us name it as A bar. Okay, remember this step. So first I have to find out the mean of these values of this experiment. So what is the formula? A1 plus A2 plus A3 up to AN divided by N. This is the mean. That means 1 by n summation I is equal to 1 to m ai. Very simple. Clear? So this is the mean, the first step. First step, it is over. I have to find out the mean of these all values or all measurements. Number 2, after finding out the mean, what I have to find out? Now I have to find out the absolute error. The absolute error. Okay, so let us discuss about the absolute error. So what is absolute error? First of all, find out. And absolute error is denoted as in this manner, del A. Okay, so absolute error is nothing but, remember, absolute error we find out for individual experiments or individual measurements. Sorry, for individual measurements. Okay, so that means for measurement A1, for measurement A2, for measurement A3, and also up to measurement AN. Okay, so absolute value we have to find out for each individual measurements. Okay, so let us find out for first measurement. So absolute error is equal to, suppose first I have to find out, this is my heading, absolute error. That's why del A1 for the first experiment. So what is the absolute error for the first measurement? It is the difference between the true value, it is the difference between the mean. Mean means let us take the mean as a true value. So it is the difference between, remember, the difference between the mean, okay, and the measured value. Again, it is the difference between the true value or the mean with the measured value. So del A1 is equal to A bar, okay, A bar minus A1. Clear? Similarly, for the second measurement, that is A bar minus A2. So in this way we have to find out the absolute error for individual measurement. I will again repeatedly told it is find out, I have to find out for individual measurement. So del A1 is equal to A bar minus A1, del A2 is equal to A bar minus A2. Okay, so it is moving up to del AN is equal to A bar minus AN. Okay, clear? So these values del A1, del A2, del, listen very carefully, these values are either positive values, either we will get positive value or we will get negative values. Clear? Okay, so these results, either we will get a positive value or we will get a negative value. So that's why what we will do, the next absolute error, that is next is your average absolute error. Average absolute error, next part is your average absolute error. Clear? So when performing the average absolute error, what we will do, now we have to take the average of this. But remember, as I told you, these values either can be positive or can be negative. That's why the average absolute error is denoted as del A bar. So del A bar is equal to, del A bar is equal to, listen very carefully, so that is del A1 mode. Look at here, mode. Why? Because it can be positive, it can be negative. So we will take the only positive value. So del A1 plus del A2 mode. So it is moving up to del AN mode divided by, very simple. Clear? Okay, so this is 1 by n summation I is equal to 1 to n del A I mode. Clear? So first mean, second absolute error for individual measurement. Here I have to mention for individual measurement. Okay, so and this is next, third is your average absolute error is this much. Clear? Then fourth point, come to here. So let us take the fourth point, average absolute error. After that, so after finding out the average absolute error, now very importantly, now we can represent the measurement or the value, okay, of that physical quantity in this manner. So representation. Next is your representation of Okay, so we can represent the value of that measurement of physical quantity A in this manner. So how will represent? The representation. Next is your representation of values. Okay, of physical quantity. Of physical quantity A. So what is the representation? Now A is equal to, look at very carefully, A is equal to, that is A bar plus minus del A bar. This is the representation. Again I will repeat. So this is the representation of the values of any physical quantity. Okay, what is the representation? Now A bar plus minus del A bar. So what does it mean? It means the value of that physical quantity ranges between two values. What are the values? Now the values are A bar plus del A bar 2, A bar minus del A bar. Understood? So the values of that physical quantities ranges between these two things. Clear? Okay. So next, number 4. Number 4, what we have to going to calculate? Now relative is your relative or fractional error. Relative or fractional error. The next is you are going to find out, that is relative or fractional error. So what is the definition? Let us find out. So relative or fractional error is denoted as del A. This is the symbol. Okay. So it is the del A. It is the ratio between. Remember, the del A is nothing but the ratio between these two. The ratio between this value, that is your average absolute error divided by mean. Remember, it is the ratio between del A bar divided by A bar. Okay, so relative error or fractional error, again I will repeat, relative error or fractional error is the ratio between the average absolute error divided by the mean of that physical quantity, the values of that physical quantity. Clear? And last but not the least, very good, last but not the least, we are going to find out the percentage of error. Percentage error. Okay, so simple percentage error is your, suppose that is your percentage error is equal to, that is del A bar divided by A bar into 100. Very simple. That is the percentage of this relative or fractional error gives me the percentage error. Understood? So percentage error is equal to del A bar divided by A bar into 100. So that is the percentage error I have to find. To find out the percentage error, what we have to do? Now we have to just find out the percentage of this fractional or relative error. Understood all of you? So this is the process. Remember, this is the process to calculate the random errors of a physical quantity, any physical quantity. Understood all of you? So this is the process. So very importantly, this is the process. Listen very carefully. First we have to find out the mean. Second, we are going to find out the absolute error. Third, we are going to find out the average absolute error. But we are very much careful that during the performing the average absolute error, we have to take the modes, because these values, these absolute error values of individual measurement can be positive or can be negative. Okay, so that's why the modes are there. So after performing the average absolute error, then we will represent the value as in this manner. Clear? The number 4, we are going to find out the relative or fractional error. Clear? So it is the ratio between the average absolute error to the mean. And thirdly, lastly, the percentage error is nothing but the percentage of this relative or fractional error. Understood all of you? In the next video, we are going to solve a problem on this. So don't worry, students. Okay. So just going through the steps. Remember the steps. Okay, and in the next class or in the next video, we are solving a problem on this. Okay, thank you. Have a good day.